With the growing need for sustainable use of energy and conservation in the residential sector, more and more residents are inclined for adopting sustainable refurbishment options for lowering and improving their utility energy consumption, from traditional methods to more technological solutions for the purpose of saving cost, monthly bills, and being a part of green community. As per the scope of this video, we highlight parameters including data analysis of monthly energy consumption, energy demand reducing options, and on-site energy generation methods. UAE lies at the crossing of Tropic of Cancer, which makes the weather in Dubai to be warm and sunny. It's summer, it's mostly hot and humid with a temperature of 40 degrees Celsius and average humidity above 90%. In winters, the average temperature is 25 degrees Celsius, while nights are comparatively cooler with 5 degrees Celsius near the mountains. The rainfall period is occasional and averagely lasts only for 5 days. The villa selected for analysis is the Ceder Villas Villa K15 in Dubai Silicon Oasis. It is a ground plus one villa with 3 bedrooms and a small garden at the back. The orientation of villa is such that it faces the north. Due to this orientation, the villa receives direct sunlight from the east till morning 3 p.m. approx. With respect to the orientation of the villa, the wind blows in the northwestern direction, hence the backyard is accustomed to a good amount of wind as sunlight. The average wind speed varies from 4.3 meters per second to 6.1, thus making the villa a good option for harnessing both wind and solar energy.
The existing AC system used in the villa is split AC system with separate units to cool each space consisting of different unit sizes. This helps better control the energy usage as per demands. The current system uses R22 refrigerant, which is not suitable firstly because it was discontinued after 2010 because HCFC contributes to ozone depletion, and the better solution for refurbishment would be replacing the refrigerant by R410A as it has HFC, which does not contribute in ozone depletion. It is more reliable and efficient. Also, it can absorb and release more heat than R22 and it increases the compressor life. Turning up the thermostat just 2 degrees can reduce energy consumption by an average of 16%. The client has admitted to forget switching the AC off numerous times prior leaving home. This may or may not have negative impact on the energy demand depending on the time the house is unoccupied. During the day, there are a lot of heat gains due to which the house tends to heat up a few degrees, thus requiring more energy from the AC to cool the house to provide optimum thermal comfort levels. Instead of switching off the AC if left on at 24 degrees throughout the day, it can be a better alternative than turning it down to 20 degrees after returning home from a hot environment.
The use of natural light is a very important component in any well-lit space. A lot of natural light enters inside the villa through the glass from the frame doors and windows. The alignment and orientation is designed in such a way that the sunlight does not reflect. Skylights are a very important part of this villa as they are installed in all the washrooms, thereby reducing the need to switch on lights during the daytime. Energy-saving light bulbs are used in all the rooms, especially in the kitchen where lights are very focused.
The southern facing side of the villa receives a lot of sunlight, making the northern side limited to it, and hence allowing the users to switch to artificial lights. Because of this, the curtains are being drawn, minimizing the natural light. To overcome this energy wastage, daylight sensors connected to electric curtain system can be used. The sensors detect the amount of daylight outside and depending on that either retract or draw the curtains to maximize the amount of natural light entering. These sensors can also be connected to the lighting system in the house and thereby adjust the lighting levels within a room. Installing insulation could also be an option to decrease the energy consumption. However, we will not be using this method since the payback period is very high, almost around 9 to 10 years.
Turning to renewable energy not only reduces the emission of greenhouse gases but also improves the air quality, ensures energy security, and boosts the local economy. There are a few factors which have to be kept in mind while selecting the most appropriate options, which include cost, effect on occupants, and accessibility to materials. The on-site renewable energy installation can include incorporation of a solar water heating system, which provides 75% of hot water requirements of the villa. This installation is fitted with an insulated storage tanks and pipes and has a negligible maintenance cost. Solar water heating can reduce CO2 emissions of a family of 4 by 1 ton a year if replaced by natural gas or 3 tons a year if replaced by electricity. Other on-site electricity generation methods can include installation of a monocrystalline silicon photovoltaic panels. These panels can be fixed on roof, facing the south direction at an angle of 30 degrees. They help in reducing HVAC demand since the heat came through the roof is lowered. They are environmental friendly since they do not give up any hazardous chemical even when they are disposed of. Thus, in conclusion, I would like to mention that Villa K15 obtains an average electricity bill of 1,300 per month. It can be noted that the higher the bill, the higher is the carbon footprint achieved, as shown in the DEVA bills. However, in order to minimize these costs and the carbon footprint, the above stated refurbishment options and renewable methods mentioned would prove to be an effective solution to achieve the main goal or self sufficiency. Thank you for listening.